Hello. Hi, everyone. This is Ruthann, and I'm going to be working on making an air quality index for summer air in Maryland. So let's get right into it. So, summer. This is the time to go out for a run, go to the pool, go to the beach, chill out. This can all be so great, so fun. One thing that can really mess it up, though, breathing issues. And that's what can come with the heat and humidity of the summer. The hot air can cause airway inflammation, and with all that blood going to your skin to keep you cool, that's less blood going to your lungs, which can cause shortness of breath. Also, the fine particulate matter that's always in the air due to pollution can really cause more problems in the summer with more people being outside. So it can actually cause long-term breathing problems with prolonged exposure. Otherwise, the heat, humidity, fine particulate matter, and other air quality measures especially affect those with pre-existing breathing issues, such as the older generation, otherwise known as the elderly. So we're going to be looking into that today, trying to track what counties or areas in Maryland have possible bad air and seeing how many or if there are large groups of older people that are going to be affected by this. So some classic measurements of air quality are heat, fine particulate matter, humidity, and ozone. I have found data for heat and for fine particulate matter. So that's what we're going to be working with today. So this is what the final product looks like. And we're going to be making a slider web app on ArcGIS Online. So yeah, that's what we're going to be doing. The darker purple regions signify worse air quality. The light yellow is good air quality. And when you slide it, it brings up these gray bubbles, and that shows a proportion of people over 85 in a county. So if somewhere is dark purple and also has a large gray circle, there are a large amount of the elderly people in that county are in danger. So that's that. But now that we have our goal in mind, we need to prepare the data for mapping. So first thing to get is the fine particulate matter. I got that from the Centers for Disease Control, their Wonder platform. Fine particulate matter are dust particles that are 2.5 micrograms or less in diameter. And because they're so small, that's why they can get deep into your lungs and cause so many problems. But this data is offered only for the United States, and the smallest unit that they have is for the county. So that's the size we're going to be using for the rest of our analysis. The latest readings that they have is up to December 31st, 2011. So it is kind of old data, but that's the best data that we have. So that's what we're going to use. Section 3 lets you choose your date, and since we are focusing on the effect of heat, I chose a time during the summer, and in order to get a good spread of data, I chose a few days in the middle of summer, so around June 10th through the 20th. And I'm going to keep those dates that I'm using consistent for the rest of the analysis. And in section 4, it has options to download as a range or as a list. I chose as a range, and due to that, it gives each county 65 rows. And in each row, it counts how many times during the 10-day period that the corresponding measurement was recorded. And this leads to about 2,000 lines of data for that 10-day period, which is insane. But to extract that data, we have to look at the total lines. So in section 5, it allows you to select show totals, and that creates a line where that averages the particulate matter for that date range. So I extracted those total lines from all of the rest of it and saved it as a new CSV, which I could use in ArcGIS Online. So with the heat data, I got that from the National Oceanic and Atmospheric Administration, NOAA, and particularly their National Centers for Environmental Information. This website has detailed climate information for the United States and has some coverage for other countries in the world. I particularly used their daily summary climate data section, which has average temperature, maximum temperature, minimum temperature, and temperature at observation. So That's really what we need for this analysis, and we're going to be particularly looking at maximum temperature. So if you're not looking for temperature and you want other information, in daily summary climate data, they also have precipitation, sunshine, wind, sky cover, and other measures like that. So if you're looking for climate data, NOAA can be a good place to go. The only warning that I have is that the NOAA data is quite spotty. So I had to go through all the lines and average the max temperature for each station and then extract those averages to use as a CSV file. So when you're downloading data, make sure to have it as a CSV. Of course, choose that June 10 through 20th timeframe. Select geographic location so that you can get latitude and longitude, which will make it really easy to graph later. And of course, choose air temperature. That gets you all 4 of those readings, but we only really need max temperature. But why not get all of them? So having such a small order, it will get in your inbox in minutes. So I'll be nice and quick. The last data that we need is county outlines, since we're dealing with counties. So to get those boundaries, you can follow this link, which was provided to me by Charlie. Thanks, Charlie. And choose counties subdivisions for Maryland. And then to get the age data, we're actually going to get that. That's also from the census, but we're going to be streaming that from ArcGIS Online. So once you actually download the boundaries, it has a column called County FP. This is a unique ID for each county. So you need to figure out which county goes with each ID, and then you'll take those identifications and bring them into the particulate matter document. This is going to be useful for joining later. With all that prepped, it's time to get into the workflow. This is the workflow for what we're going to be doing today. Just wanted to show you. In the documents that I gave Charlie, I will provide my workflow if you wanted to follow along and do it on your own. But yeah, with all that prepped, now it's off to ArcGIS Online. All right, everyone. Now that we are on ArcGIS Online, we can get started with the analysis. So if you'd like to follow along, please reference the workflow or just follow along with the video. So of course, the first thing we do once we get on our platform is to upload all the prep materials. So that for this includes like the counties, which is right here, that came in as a zip file, the particulate matter, which came in as a CSV, and the air temperature. And that comes in over here because it has latitude and longitude data. So the first thing we're going to do is to create coherent counties. So as you can see, some of the colors are together, but they have all these small parts because we got counties as subdivisions. So what we need to do to fix that is to merge them all together, which is actually with a tool called Dissolve Boundaries. So if we look at the attribute table, you can see they have these things called County FP. And if you put it in ascending order and you select something with the same County FP, for this example, 1, it selects everything within the same county. So we're going to dissolve boundaries based on this county FP. You would find dissolve boundaries if you go to analysis right here, then manage data, and dissolve boundaries is the first thing there. So you would just use this tool based on county FP. Based on county FP. So once you do that, you would get this. I'm not sure what all the speckled spots are, but all the outlines are of the counties. So that's what we need. Now that we have that, we'll use that later to show outlines for all the counties. The next thing to do is to join the particulate matter to the counties. So we do that using a regular join. You find join on ArcGIS Online by going to analysis, then summarize data, and then they have join features. It's very similar to on Arc. You choose how you join it to, whether it's field match. So in this case, it is field match. and you would match it to that county FP field that we added in. So once you do that, you'd get a join that looks like this. So as you can see, it has the county shapes, but if you go into the attribute table, it also has particulate matter numbers. So now that we have that step down, we need to work with our temperature data. As you can see, it's randomly, well, kind of randomly throughout the state, but there's not coverage in every county. Like this county, for example, doesn't have one. This county, for example, doesn't have one. But for this analysis, we need data everywhere. In order to do this, we will interpolate. You will find interpolate by going to, we would do this on the temperature. So you'd go to analysis and analyze patterns, and interpolate points is right here. So we would choose the max average, which we made. That is what we're going to interpolate on. And because we don't have that many points, we're going to optimize for accuracy. This will make it take a little bit longer, but it's definitely worth it in the long run. And then you just hit run. Once this is done, you'll get something that looks like that. Gets a really nice colored map. In this case, our information is pretty linear, which is why it looks pretty linear. If this looks too perfect, feel free to run the interpolation again, and maybe you'll get something a bit different, but this is the interpolation that I ran with. So once we have that interpolated, we have to get it to fit inside the county, since we're visualizing via counties. So how I did this was using a tool called overlay layers. So I imagine overlay layers to be like cookie cutters. So it's using the boundaries of one layer and the boundaries of another layer as if they're two cookie cutters that are going over each other. So it makes their own individual shapes that hold data from both sets. So in order to find that tool, you would need to go to, of course, analysis, then to manage data and overlay layers. You would just choose which layers. Then for the overlay method, I chose intersect. And now that we've used the overlay tool, it creates this layer. So it's visualizing via county FP, which is why it looks very similar to a previous one that we're looking at. But if you look closely, you can see that some counties are split into varying parts. You can see that even better in the attribute table. So Anne Arundel County has two parts. It comes in there twice. Baltimore County's in there a few times, and it keeps going like that. So that's the intersect. So now each area has particulate matter in it, which is right here in this column, and also value min and value max. Value min is the minimum temperature found by the interpolation, and value max is the maximum temperature found by the interpolation. So now we have our temperature data, we have our particulate matter data. Now it is time to make a composite score. We're going to make this score first by normalizing each value, and then we're going to add those two normalized values together. We're going to normalize these values using a classic equation to normalize things, which is x minus min x all divided by max x minus min x. And we'll be able to do that using what in ArcGIS would have been field calculator, but in this, it is arcade calculator. So in order to do this, we're going to need to make a couple columns, make a couple fields. So I added an additional field over here, which is titled wrong because I couldn't change the name, but this is the normalized temperature. This is normalized particulate matter, and then we're going to combine them. So let's show you. I'm going to show you how to first add a new column. You would go here to these three lines, and then you would, you would add field. Then you'd get to name it, choose a display name. The type you're going to use is a double, And let's just add one into test. And then it will save it. And that's all you need to do to add a new field. Now at the end here, test. So once you have a field, then you would do field calculator on it to normalize, as we were just talking about. So you click on the column, the field, and then you go to calculate. There are two options that you can use to calculate things, and they're in two different coding languages. There's Arcade and SQL. I'm not familiar at all with SQL, which is why I chose Arcade. And Arcade looks like this. So if you're not familiar with coding, don't be too scared from it. They give some great notes up here as to what things look like. You just need to follow this format. So when you're using Arcade Calculator to normalize, we're just going to follow this format. You're going to do $ feature, and actually you don't fully need to type it actually, let's go back real quick. We're going to be normalizing, you gotta get the name of it. So this, we'll do value max for the example. Value max. So since we need maximum temperature, we're looking at the effects of extreme heat, gonna use value max. So remember that name. Gonna do it in this test column. Calculate there, Arcade. And we're going to do, since we're looking at the feature, which is essentially the attribute table column, so we're going to do feature value max. So we can scroll down so we make sure not to type it wrong. And once we put our cursor in there, we click it, it adds it in. So we need x minus min. And min is actually a function, so let's scroll down in their functions. And once you're in this function space, you can click the I and they'll tell you how they want you to set it up. So for min, they want you to put values and then the field name. And we'll do it right now so you'll see how it goes. So once you return to the function list, you can click it, it enters it, min, and it has that holding space for values. So the values we're going to use is layer, and the field name we're going to use is value max, and you put it in single quotes and you keep that space there. So value max. Let's put some parentheses around that, follow PEMDAS, and then we need max and min. So have some other curly braces, let's click that max. And it doesn't mind spaces, so we can enter that so we can just see most of it. So max, again, gonna be layer, value max, minus min, layer, value max. Read it over, make sure you did it right, and you have all the parentheses that you need, and then you can hit test. Test will show you if you actually get what you want. So the result for this one is 0, and then the type is number. And since we made it a type double test, it's supposed to be a number. So once we do that, it should be good. We hit OK, which applies it, and then it runs. All right, so let's see what's in this test folder. Since we normalize it this way, everything should be in between 0 and 1. So the first one is 0, as it said, then 0.4154, just like this other column that we did. So that's done correctly. And you follow the same procedure for particulate matter, except instead of value max, you would put PM, since that's the name of the column, or whatever the name of your column is. And then you would still go into that Arcade calculator again to get that combined number, which would be these two added together. And instead of that really complex calculation, it would be, once it loads, it would be feature dot, let's get that spelling right. It would be feature dot compare on plus feature norm PM, I think is what it's called. And that's all you would do. Test, and then that's your number. Please note that what's in Arcade Calculator doesn't save. You can't go back and edit it. You'd have to rewrite it every time, which is why even though combined norm is already field that has things in it, there was nothing in Arcade Calculator. So just know you have to redo it every time. But this is what you do to get it. Since it's already in there, I won't hit OK. But yeah, now we have combined norm. So this is the column we actually want to visualize on. So let's go to visualize, because this is our combined value. Visualize, go to combined norm. Let's pick a color that we like. I quite like how the purple looks, so we can go to options and then hit symbols. They have all these pre-done ones. I quite like this purple. And then if you want to invert it, you could do it here, or change anything else. And then you hit OK. And done. And there you go. Now we have a really good looking gradient map. And if we move this MD counties on top of it, which, as if you may recall, it has the outlines of all the counties, now you can see the counties with it. So this is a pretty good looking map right here of air quality in the counties in Maryland. So the one thing that's missing that I highlighted previously was age data. And as I said in the PowerPoint, we're going to get age data from the census, but we're going to stream it through ArcGIS Online. So when you go to add, you'd go to add and use browse living atlas layers. And for this, since we're looking for counties, we're just going to search counties. Enter there. And we're going to use this USA counties. I've already added it, but you can click this plus right here to add it. Then you'd go back, and now we have USA counties. And this is what it looks like. Just has all the counties for the country. But the thing is, we don't need all the counties for the country. We just need the ones from Maryland. So to essentially do a definition query on it, we're going to use this filter tool. So you'd hit filter, and you would filter by, let's scroll through to look at it. We're looking for something that's called state FIPS. Every state has an ID, and it's called state FIPS. And the state FIPS for Maryland is 24. So apply this filter. And we should only have the counties for Maryland. Perfect. So now we have that, we're gonna get the age data for these counties in Maryland, particularly those who are older than 85. So and since that's what we're gonna be visualizing, let's go to visualize right here. Right now it's on show location only, but we're gonna go to age data. So we're gonna look at those that are age 85 and up. All right, and out of the options that it gives us, I actually quite like this dot, so we're gonna use that. But these numbers aren't good to compare to each other. It makes more sense to normalize them by the population within that county. So we're gonna go to options and use that divided by, scroll until you find pop 2010, because that'll be the population for each county. And then we're gonna hit OK. So with this done, this changes it to normalize by each county. And while you're in here, you can change how those dots look. You can specify the range. You can change a bunch of stuff. There's transparency. There's a whole bunch of stuff you can do. But we're just gonna leave it how it is for now. The only thing we're gonna change is its color, because that orange is not quite flying with me. I think a dark gray would look good. Nice, sleek. So let's go with that. And now that this is done, this map is almost complete. The only thing we have to do is move it to become an app. So remember, what I haven't done this whole video is save. You still have to save on your own, because of course it's Esri product. So remember to save. Once it's saved, then you can go to share, of course, share with Skidmore, and then create a web app. I already have a web app created, so we'll go to there. All right, so now we're in the web app. Since it's already finished, this is what it looks like on the opposite end, but let's go to builder mode. And when you first make a web app, it brings you to the settings page. So we'll go in there as well. So in the settings, you're gonna choose a vertical bar. We're going to swipe the layer that's on top. That's why we left that USA counties on top. So we're gonna swipe that USA counties, enable description. Essentially just keep what came with. I didn't do this pop-up part since I don't have any pop-ups. Didn't change the theme or anything, kept the Esri logo, and kept that same extent. And then you just hit apply. And there we go. You just add a nice description here, and there you go. Works pretty nicely to slide, and this is how you do it. This is how you make this map. And thanks for following along. If you'd like a link to this finished map, it's going to be in our shared. If you follow the teaching handle on our ArcGIS Online, you can easily find this map. Remember to save, since you still have to do that on your own, and that's how you would finish it. Thanks for watching, guys.